In this example, I need to solve the inequality and write the answer in interval notation. The inequality is x squared minus 8x plus 16 is less than 0. Well, what type of inequality is this? Notice the highest exponent on an x is a 2, so it's a quadratic inequality, which is just a special case of a polynomial inequality. And here are the steps for solving polynomial inequalities using the boundary point or critical point method. Step 1 says to find the boundary points by changing the inequality to an equal sign and solving the resulting equation. The real solutions of this equation are the boundary points. So in my example, I'm going to change this less than to an equal sign. So I'm going to get x squared minus 8x plus 16 equals 0. And what type of equation is this? Notice it's degree 2, a quadratic equation. So I'm going to try and solve it by factoring, and if that won't work, then I'm going to use the quadratic formula. As the coefficient of the x squared term is a 1, this is one of the simpler ones to try and factor. So I need to look for two numbers that multiply to the constant term of positive 16 and add to the coefficient of the x term, which is negative 8. Since my numbers multiply to a positive, the signs are the same. If they add to a negative, both of them have to be negative. Hopefully these numbers come to you quickly, but if they don't, I'm going to show you the systematic way of doing it. So negative 1 times negative 16 multiply to positive 16. But negative 1 plus a negative 16, add to negative 17, not the number I'm looking for. Does 2 divide into 16? Yes. So I have negative 2 times negative 8 is positive 16. Negative 2 plus a negative 8 is negative 10. Not the number I'm looking for. Does 3 divide into 16 evenly? No. Does 4 divide into 16? Yes. So I'm going to have negative 4 times negative 4 is positive 16. And negative 4 plus negative 4, this is looking good, add up to a negative 8, the number I want. So these are my two factors. So I'm going to have x minus 4 times x minus 4 equals 0, which we can write as x minus 4 all squared equals 0. And x minus 4 all squared equals 0 when x minus 4 equals 0. Add 4 to both sides, we have x equals 4. So in this case, I only have one boundary point, and that is x equals 4. So I have now completed step 1. Step 2 says place the boundary points on a number line in the correct numerical order. This divides the number line into intervals. So here is my number line. I need to put my boundary point of x equals 4 on the number line. It divides the number line into two different intervals. One that's less than 4 and one that's greater than 4. So I've now completed step 2. Step 3 says choose one number called a test value from each interval and determine if the inequality is true or false at that value. Select the intervals where the inequality is true. So I'm going to need two test values. Let's pick one in this region. So I need a number less than 4. I'm going to pick the lazy arithmetic problem of x equals 0. Plug it into the original inequality. So I get 0 squared minus 8 times 0 plus 16. Is that less than 0? First two terms turn to 0, so I just get is 16 less than 0? That is false, so I do not want this region here. Let's pick a point over here where x is bigger than 4. Let's pick x equals 5. Plug it into the original inequality. I will get 5 squared minus 8 times 5 plus 16. Is that less than 0? 5 squared is 25, minus 8 times 5 is 40, plus 16. Is that less than 0? 25 minus 40 is negative 15, plus 16. Is that less than 0? Negative 15 plus 16 is 1. Is 1 less than 0? That is also false. So I do not want this region. So looking at our steps, I have completed step 3. Step 4 says the boundary points are included in the solution set if the inequality is greater than or equal to or less than or equal to, and we use square brackets. The boundary points are excluded from the solution set if the inequality is greater than or less than, and to use parentheses. So my boundary point of x equals 4 is excluded from the solution set, and I have no intervals where the inequality was true. So what is the answer to this inequality? There is no solution, as there is no value for x for which this inequality is true. And if we want to write the answer in interval notation, it is often written as the null set. But before I go, I want to point out one other thing. What would happen if the problem had been x squared minus 8x plus 16 is less than or equal to 0? My boundary points would have been the same. I would have tested intervals the same. The only thing that would be different is the boundary point would be part of the solution set. So the solution to this inequality here would just contain one point, the boundary point, and the way we write that in interval notation is we put the 4 in braces. So if I change the inequality to less than or equal to 0, the solution would just contain one point, the number 4.